Hello everyone, welcome to my YouTube channel. I am Harshita from Sri Venkateshwara College of Engineering. In this video, let us discuss the test of significance for large samples and the comparison of large samples. Let's see the introduction to test of significance for large samples. Test of significance is a statistical method used to determine if there is a significant difference between two or more groups. Large samples refer to data sets that are sufficiently large to make reliable inference about the population. In this presentation, we will explore the test of significance for large samples and compare different large samples. Let's see the overview of large sample testing. Large sample testing allows for more accurate and reliable result compared to small sample testing. With large samples, the central unit theorem ensures that the distribution of the sample means approaches a normal distribution. This allows us to see parametric test assuming the data follows a normal distribution. Let's see Z-test for large samples. The Z-test is a statistical test used to determine if the sample mean is significantly different from the population mean. For large samples, the Z-test is approximate when the population standard deviation is also known. The test statistic is calculated by using the formula Z is equal to X bar minus mu divided by sigma divided by root n, where X bar is the sample mean, mu is the population mean, sigma is the population standard deviation, and n is the sample. The t-test for large samples. The t-test is used when the population standard deviation is unknown. For large samples, the t-test approximates the z-test as the sample size increases. The test statistics is calculated by using the formula t is equal to x bar minus mu divided by s divided by root n, where x bar is the sample mean, mu is the population mean, s is the sample standard deviation, and n is the sample size. And next, let's see one sample Z-test example. Suppose we want to test if the mean weight of a certain breed of dogs is significantly different from a known population mean. We collect a large samples of weights from this breed and calculate the sample mean and the sample standard deviation. Using the Z-test, we compare the sample mean to the population mean to determine if there is a significant difference. Now let us see an example for one sample t-test. Suppose we want to test if the mean IQ of certain group of students is significantly different from a known population mean. We collect a large samples of IQ scores from this group and calculate the sample mean and sample standard deviation. Using the t-test, we compare the sample mean to the population mean to determine if there is a significant. Now, next, let us see the assumption for large sample testing. Large sample testing assumes that the data is randomly sampled from the population. It also assumes that the data follows a normal distribution, especially if the sample size is small. Additionally, large sample testing assumes that the observations within the samples are independent. Now, next, let us see the interpreting results. When conducting a test of significance for large samples, we calculate a p-value. The p-value represents the probability of observing the test statistic or more extreme value, assuming that the null hypothesis is true. If the p-value is less than the significance level, typically 0.05, we reject the null hypothesis and conclude there is a significant difference. Now, next, let us see effect size. In addition to testing for significance, it is important to consider the effect size. The effect size measures the magnitude of the difference between the group regardless of statistical significance. Now, next, let us see the limitations of large sample testing. Large sample testing is not without limitations. It assumes that the sample is the representative of the population, which may not always be the case. Additionally, large sample testing may be appropriate for small population or when the data does not follow a normal distribution. Next, let us see the sample size determination. Determining the appropriate sample size for large sample testing is crucial for obtaining reliable results. Factors to consider when determining sample size include the desired level of precision, expected effect size, and the statistical power. The power analysis can help to determine the sample size needed to detect a significant difference. Now, next, let us see some of the practical applications. The test of significance for large samples is widely used in various fields such as medicine, social science, and business. It helps researchers and the practitioners make informed decisions based on statistical evidence. Large sample comparison allows for reliable conclusions, leading to better understanding and the improvement in various domains. Now, finally, I conclude that the test of significance for large samples allows us to compare groups and make an informed decision. Large sample testing uses parametric testings like z-test and t-test, assuming that the data follows a normal distribution. Consideration of effect size, assumption, and proper reporting are important in concluding and interpreting large sample test. Thank you for watching my video.